Hooray. Okay, so yeah, I'm Joseph. I'm from uSwitch. You may be thinking, why does these slides say RVU? That is our collective name for uSwitch, money.co.uk, and bankrate.com. New branding. Woo. So yeah, I'm going to be talking a little bit about background. So at uSwitch, historically, we had every single development team running their own infrastructure. So this meant they were running on either EC2, ECS, Puppet, all sorts. They had a lot of different ways of doing things, a lot of different metric systems. They were totally independent. And a few years ago, we started moving to kind of shared Kubernetes clusters. So when this happened, we brought along all our systems with us. So we had a lot of different metric systems. It was a hodgepodge. Nobody knew which one to use. So there was a lot of places to look. If you're on one team and you're like, this app isn't working, where do I look? Oh, is it on this system? Is it on this system? Etc. And like a lot of different ways of doing things just between teams. It's like one team's trying to push metrics somewhere, one team's interacting with the AWS API, or some teams are just using Prometheus. So we thought this wasn't very good. Like let's just have one way of doing it. Let's have everyone do the same thing. So we set out some requirements. We thought, what do we need from a metrics platform? I think two of the important ones from that list are highly available. Like we needed to be able to rely that our metrics are going to be there if we know alert on them, and also powerful query language. Like we have a lot of analysts at uSwitch. People love doing crazy queries in BigQuery, and we wanted to have similar levels of maths that you could do in a metric system. So we did a kind of review of all the different metric systems we thought looked good, and the winner was not Prometheus. No, that didn't win. So yeah, we experimented with a vendor solution, who I won't name, for a while, and it was good. I mean, it was HA. It was took all your problems away from a lot of, infrastructure perspectives that we care about, but developers didn't like it. It couldn't do all the cool queries they wanted to do. The dashboarding wasn't what they wanted, etc. And we didn't want to force them to use something they didn't like. So we went back to the drawing board. We went, can we make Prometheus work for us? So to explain that, this was our current setup. So we have 3 Kubernetes clusters. In each Kubernetes cluster, we would have a single Prometheus instance, and we also had this crazy thing over on the right, which is the Supreme Prometheus, which was effectively just scraping the federate endpoints off the other Prometheus instances, which meant you could kind of try and get all your metrics in one place, but you were just duplicating them all, and it fell over all the time, and we used to filter out metrics to try and make it not fall over, and it wasn't great. So yeah, problems. It wasn't HA. There was no HA. If Prometheus goes down, you've got no metrics for 5-10 minutes until it comes back up again. If you're just trying to do a rolling upgrade, this gives you downtime. There were still too many places to look. Each cluster, you have your own Prometheus, you have to go look there. It used to fall over a lot if we had long retention, so we had about 14 days, I think, before it started exploding. And yeah, individual teams would sometimes go, oh, I have a fancy new query I want to run over this 14-day period. Let's take a massive histogram and divide it with another histogram, and everything fell over, which wasn't great. So we saw Thanos. We're like, this sounds good. It seems to do a lot of the things we wanted. And yeah, so we kind of experimented straight away with this. This is just a very basic Thanos step. I don't know how much people are aware of Thanos, so I'm just going to quick explain it. Is that Thanos has a sidecar which you attach to your Prometheus instances, and then you have a query, which is just another component which sits on top of those Prometheuses, or Prometheis. So this means you can just load balance between your Prometheus instances effectively. It's most basic. You put this in front of it, it deduplicates the metrics, so you don't get double the metrics back. So if one of these goes down for 5 minutes, or if you're doing a rolling update, you don't have any gaps in your metrics. So it's great. Okay, got a little bit of HA. Now we can expand this to all our clusters. So we have this query component sitting in each of the clusters, which gives us that HA Prometheus. But we can tell the query component to go and talk to the queries in the other clusters, and then this just gives you all the metrics from all the clusters from one query. So we're getting somewhere at this point. I've got all my metrics on one endpoint. Now, we kind of did something a bit more with this. Is we have our own setup with Envoy and something called uDristle, which is a way of configuring Envoy based on ingress resources. And again, won't go into too much detail on this. Feel free to check it out. It's on GitHub. But effectively, this allows us to load balance between our Kubernetes clusters. So anyone can just go in at that web address of thanos.uswitch.com, and they would hit any one of our Kubernetes clusters and get all of our metrics back all at once. So at this point, we'd got this one URL which a developer could go to, and they could see all the metrics across all the clusters. And it also, Grafana plugs straight into this. You just say it's a data source in Grafana, and now Grafana has all the metrics from all the clusters. Cool. So the second thing was long-term storage. Thanos stores all your long-term metrics for you away in S3. It has a secondary component called the Thanos store. This just goes and queries S3. So think of it like a Prometheus instance, which is backed by S3 as its storage almost. It's just exposing a Prometheus API. As far as the Thanos query is concerned, it's almost like it's just another Prometheus instance. And yeah, so this means you don't have to have long-term retention on your individual Prometheus instances anymore. I think we set it to a day at this point is all we actually have on our Prometheus instances, and the rest goes into the store. And again, you can scale this up to all your clusters, so you can have all the stores in all the clusters, and you have just one. Again, it's like if you query one store, you can get the metrics that all the other stores are plumbing into. So at this point, we have quite good HA. So if we have explosions, which often happens when doing kube upgrades, we still have access to almost all our metrics. So if you follow the code path down, you go through Envoy, you go down to a Thanos query. This has access to all the kind of running metrics in the cluster via the queries. It can also go back up to that long-term storage, which all the other clusters were writing to. So it has all the historical metrics from all the other clusters, as well as the kind of up-to-date metrics from the cluster it's still in. This means in the event of a total cluster catastrophe in 2 out of your 3 clusters, you would still be able to at least see what was happening up until the point they exploded. So this was pretty good. At this point, we'd got fully HA Prometheus. We had one endpoint which we can view all our metrics on, and we no longer have to store them all locally on disk. But now we can do more. So while we still had we still had HA Prometheus, it was still one Prometheus per cluster. We just had 2 of them now for failover. So this still left it open to some of the same problems we had before, such as just a crazy query from a developer can take it out. It'll just take out one of them this time. But if they keep doing that query, it can take them both out. So we thought, okay, we still need to make this more reliable. So the answer to this was many Prometheus. So this is the Prometheus operator. It's by CoreOS. It's very cool. It allows you to define Prometheus resources using Kubernetes resources. So this is just a really basic example on the board, which is just a Prometheus object. And this just creates for you 2 Prometheus instances with the same config, and will also inject Thanos config into them, etc. So at this point, you can template as many Prometheus instances as you want very, very quickly. And we soon appeared with this kind of setup, which is loads of Prometheus, but each one is just for an individual team. So it's only scraping the metrics from their namespace, let's say. And from the developer's perspective, nothing's changed, because they're still just hitting that same Thanos endpoint. They didn't notice we'd done any of this behind the scenes. But now we're able to balance across all these tiny little Prometheus instead of just one big one. Well, this was the next query. How do we size these? So when you've got loads of little Prometheus, you'll find they use a lot different memory, CPU, etc., depending on the team. And we care about utilization and cost and whatnot. So we thought, easy solution, just make them all as big as the biggest one. But we thought we could do better. Well, we didn't do better. Kubernetes did better, which is a vertical pod autoscaling. This is a pre-new feature. It was recently moved to beta. It was in alpha when we started using it. And what it does is it watches your pod's metrics usage. And Then based on that, it can do a few different things. On its most basic, it will just tell you what it thinks you should be setting as your requests and just advise you. Just say, I reckon you should be using 2 gigs of mem. The next step, which is what we use, is you can apply these new requests whenever your pods are rescheduled. So if it reckons you need 2 gigs, and the next time that pod schedules, it'll be given 2 gigs. And then the last one is you can have it actually full on kill your pods and restart them with the new requests, which is very dangerous if you don't know what you're doing. So careful. They are currently working on in-place pod vertical autoscaling, which would allow you to actually resize a running pod on the node. It's quite complicated from a scheduling perspective, but they are hoping to get into Kubernetes soon. So there's a few gotchas we're using vertical pod autoscaling. One is don't use it with a HPA. If you try and horizontally scale your pods while you're vertically scaling them, crazy things happen. Like nobody knows, basically. Just don't do it. As I said, recreate, dangerous. You might end up with patches of downtime because the vertical pod autoscaler gets a bit trigger happy and thinks you're wasting stuff. And then this third one's a funny one. Bartek, who's here, wrote a really good blog about Go 112. But basically, it appears to use a lot more memory than it used to once you upgrade to later versions of Go 112 because of kind of caching that Go now does. This causes the vertical pod autoscaler to go nuts because Go will effectively see, oh, I've got another 2 gigs of memory on this node. I'll just kind of keep some of this and maybe use it later, but if someone asks for it, I'll just give it straight back. So it's not really using this, it's just kind of keeping it for a rainy day. But vertical pod autoscaler doesn't see the difference, so it just thinks it's using this and will keep constantly increasing your memory requests until you have our 128 gigabyte Thanos store that was couldn't fit on a node at that point. So you can currently set this off. There's a Go environment variable that will revert it. But I say we, Dimitri, he's in the audience, raised a PR to vertical pod autoscaler yesterday, which got merged in 2 hours for some reason, to change it to a different metric, which doesn't do this. So that should be good soon. Cool. Alerts. So this was another big thing. So we got this metric system. What were we using a metric system for? And a lot of it's alerting. And again, the Prometheus operator came to our rescue here in that you could just easily create alerts in a cluster using a Kubernetes resource. You just, down the bottom there, you just specify the metric you want to alert on. Basically, you put a query in and you alert on that. And we found it really useful for alerting on our kind of low-level cluster metrics. For example, pod A in cluster B is experiencing high latency or something. I found it quite useful for that kind of thing. But we found Grafana was more preferred, not just by us, but by the developers for kind of alerting on a cross-cluster kind of level. Because if you're at the Grafana level, you can kind of get a nice dashboard, map out everything, break it down per cluster, and kind of send alert is my latency across all the clusters going up or down or something like that. As well as AWS metrics. We still put AWS metrics just directly into Grafana using the CloudWatch integration, as we found that easier than kind of reinventing the wheel for that one. Yep. So this was the thing that was still killing us, was explosive queries. We'd done all this work, but we still had Prometheus just exploding because of developers. So we started moving to SLIs, SLOs quite heavily in our organization. For those of you who don't know, it's a service level indicator, which is a kind of indication of how well your service is performing, but this is over a longer period of time than what you would alert on. Standard is 28 days, let's say. If you're trying to do a query over 28 days that's very complicated, let's say, this tends to make everything explode. Again, I've said explode a lot. Okay. So if you do this on Grafana, as we found out to our peril, as an alert, every single Grafana instance you have will be evaluating this query every 5 minutes, let's say, which quickly can overwhelm all your Prometheus instances. So how do we fix this? Again, Prometheus operator comes to the rescue with something called recording rules. So a recording rule is a way of pre-computing a query over a short space of time. If you've got a complicated query, instead of doing it over 28 days, I just do it over 5 minutes, and I do this every 5 minutes. And this means that instead of having to correlate thousands of data points over a month and divide them by another 1,000 data points, I've just got these individual data points which I can plot. Is the gist of it. Great, you'll find your queries are way, way faster if you use this. So anything you regularly query and that's complicated, like histograms, things like that, is really recommended to just set up a load of Prometheus rules again, which is super simple, template this, Kubernetes. Yeah, I guess that's basically the gist of it. Like, I think the takeaways from this was actually just having a single API is really, really useful. Like once you've got one place to query all your metrics, like a operations team like ourselves can do loads of things behind the scenes and nobody notices, which is nice. And we can just add more stuff to this. Like things I didn't mention was we have like EC2 clusters not running Kubernetes, which also have Thanos and Prometheus running in them, and we just add it as another endpoint and it just gets put into the metrics pool without anyone having to change anything. It was a bit hairy at the start. We all say that when we first used it. It was, there were bugs. It was very alpha. We knew the risks, but the Thanos community was really good, actually. Like something I noticed is I don't think I ever raised an issue, and the reason for that was as soon as I found a problem, I'd go to Thanos, look at the issue, see it was open, and someone had raised a PR to fix it. So they were pretty on the ball, and. Yeah, we quickly found developers chose to move to our Prometheus and Thanos setup, which I think is the best indication of success almost, as if you're not having to force them to use it, they just want to use it because they've heard it's more reliable or they've heard it's better and simpler. And I guess like going forward, now we've got this kind of standard way of doing stuff. It's like everyone's using Prometheus, everyone's going through this Thanos endpoint. Like what can we do now? Like this kind of it frees us up a bit to kind of experiment of where we can go from there. Like so a lot of things we're looking at, things like standardizing dashboards, alerts, queries, like how simple can we make it just to make a really good Prometheus setup just out the box for a new team who's starting up. They're like, I want metrics, I want alerts, that's what they want. Can we just give this to them in a simple format? And with like these common tools, I feel like we might be able to get there. Cool. So thanks for listening, everyone. These are a load of links to some stuff I talked about. Feel free to review them. You can follow me on Twitter or email me or something if you want to talk to me. You can check out some of our open source stuff at github.com/uSwitch. And we are hiring. No surprises, but if I didn't put it in there, the HR team would get mad at me. So yeah, cool. That's it. Oh yeah, questions, sorry. Oh, sorry, yep. Good.
So yeah, feel free to ask questions, and just we'll repeat it in the microphone. Yeah. And why did you have a Thanos query again in each cluster? Whereas I thought Thanos query would be like global and it would hook up.
Okay, so let me get, I will repeat, yeah. So the question was, why do we have like these queries in each cluster? All right. So the idea here, I feel like I might need to like move around, is these queries down here, they are only responsible for their own cluster, effectively. So they just give you metrics from the Prometheus in that specific cluster. Now this querier is responsible for talking to not just that query, but this query, this query and this query. I should have gone from the other way, shouldn't I? Anyway, but so this means that, yeah, that's basically just spreading out across all the clusters and collating the metrics for you. It means if like this breaks, this still works, and you'll still get those two sets of metrics from here. It's the kind of thought behind that. So and those actually also go and talk to our like Envoy metrics and our Vault metrics, which are somewhere off the screen. But yeah.
So you talked about the Prometheus service getting
Not really. No, I mean it can still happen. Like that's why we put the recording rules in. So I don't. Thanos doesn't necessarily solve that problem. It can. Sorry, I'll repeat the question. The question was, do you still see Prometheus exploding because of queries, basically, even with Thanos? And yeah, so with Thanos you can still get. It makes it easier to mitigate against it. I find is the benefit. And that combined with the recording rules has made it to the point where we don't really see this anymore.
Thanos itself doesn't have that problem.
Oh, you mean like Thanos itself exploded? I don't think we've managed to do that to it. No, I mean most of the work goes either to the individual Prometheus via the sidecars or the store. So the query itself, I've never seen it kill or like crash or anything. No. I'm sure it's possible. That sounds like a challenge. Okay.
Any other questions? What was your experience like telling development teams that they had to reach within applications a new platform? Was that easy?
So the question was, did we get like a lot of pushback kind of trying to move development teams to this new setup of using Thanos and stuff? No, basically, we didn't get much pushback. I think the reason for this was developers, most of this stuff's quite easy, I would say, to do, right? So if you're a developer making an app, like switching between maybe using StatsD or CloudWatch or Prometheus as your metrics instrumentation isn't that much work. All things considered, they tend to have quite good libraries and stuff. So, and our devs, they like doing stuff anyway. So that wasn't a hard convince. The hard thing to convince was reliability. That was what would have stopped them from moving. If you compare it, like CloudWatch is always going to be up, right? Well, theoretically. But the same with like other kind of vendor solutions, they have certain levels of kind of guarantees that they're going to be there. And that's the thing that would annoy a development team the most, is that they just can't get the metrics, and I want to get my metrics. So it was all about reliability. And once we could prove that this was, well, it wasn't just about reliability, a lot was about reliability. And if we could make it as reliable as one of those third-party offerings, it made it much quicker to move to it. And the other thing would probably be the Grafana. Our developers love Grafana. Like, they really like Grafana, to the point that people were trying to, get like their StatsD metrics into Grafana and their CloudWatch metrics into Grafana. Everyone was trying to get into Grafana. So the fact that it integrated so easily with Grafana and with that kind of PromQL syntax and everything, that made it much more easy to push them over because they wanted to use it. Yeah.
You mentioned you've only had like a day left on your Prometheus data. I mean, the direction of travel seems going towards zero and effectively eventually getting rid of Prometheus. Can you see that somewhere on the horizon?
The question was, we've kind of gone down to 1 day of retention on our Prometheus. Would we want at some point just go down to like 0 days? I don't know. I mean, that wouldn't work with our current setup, definitely, but because you have to have at least 2 hours of retention due to the way the Thanos store works. It kind of uploads blocks to S3, and these are done on a 2-hour basis. I believe this is the minimum you can have. Please correct me if I'm wrong. That's correct. Cool. So currently we have to have at least 2 hours. We do a day just for, I don't know, because we do. Cool.
That suggests if you just have a tiny little app that can just do the 2 hours, and like just basically got Prometheus, they could be able to do 2-hour blocks and ship them up. You have to say Prometheus minus.
Yeah, maybe. I mean, the main thing is, I mean, if someone comes up with that, we'll use it. I mean, we're not attached to the thing. As long as it works, we're happy.
Wait a second. Yeah, just to finish this topic, like why killing Prometheus? It's giving like huge amount of benefits from kind of complex scrape configuration that you can do. Like it enables that from just out of the box already. Some immediate alerting, things like that. So it's kind of good. But yeah, to answer your kind of question about like can we reduce retention? Yeah, we can use other solution that pushes metrics. For example, Thanos Receive that is kind of being developed, or any other solution that will integrate together with Thanos. So that might be a solution. But if that's problematic, one more thing to the booming Prometheus or like exploding queries, like literally yesterday we kind of merged a PR with the protocol upgrade for remote read, which is kind of a critical part between Prometheus and Thanos, and it's now streaming. So we should see like dozens times like lower memory consumption and like pretty quick kind of response time as well and latency. So I hope to embed that in Thanos soon as well. Shameless plug. Okay, thank you. Round of applause for Joseph.